This is a video recording of Chapter 10, Part 2 of the notes. We'll continue where we left off on 1st April. So in example number 6, we had to use the pattern to find the integers for a and b such that a squared minus b squared is 1001. And we have already established that line n has this particular format. Now we would like to find the value of a and b. We know that a will be related to n. We know that b will be the same as n minus 1. We also know that the right hand side of the equal sign 1001 will be given by negative 1 plus 2n. So we are going to work with the right hand side because there is only one unknown and there is only one equation. So this will result in negative 1 plus 2n is equal to 1001. So to make n the subject, 2n will be equal to 1002. N will therefore be equals to 501. So once we have found that n is equals to 5001, we know that the value of a must now be equals to 500 and b will now be 500, a is 501, whereas b will be 500. Moving on to example number 7. Okay, in example number 7, we will see frequently patterns which involve diagrams like this. So in pattern 1, we see that there are 5 dots. So let's put on the number of dots at the bottom. In pattern number 2, we see that it is made up of pattern 1 with the addition of 3 dots. So it is actually 5 plus 3, which is 8. Then in pattern number 3, we see that it is made up of pattern number 1 again, but you plus another 3 to get pattern number 2, and you plus another 3. So this is 5 plus 3 to give us 11. And we see that this is going to be the pattern. And this is a question on common difference, where the difference is going to be positive 3. We are always adding 3. Term number 1 will be 5. So for A part 1, number of dots in pattern number 4, number of dots is going to be 11 plus 3, giving us 14. Okay, so in part 1, we've got 14 dots. Now in part 2, to find the number of dots in pattern number 10 will be quite tedious, but it is still doable as long as we make use of the general term. So Tn equals to T1 plus n minus 1 times of the common difference. Okay, so this will be in pattern number 1, term 1 will be 5 plus n minus 1 times of 3. That is our common difference. So this is 5 plus 3n minus 3, simplified to become 2 plus 3n. As long as we know the term number, we will eventually be able to find the value of the term by substituting the corresponding value of n. Now term number 10, or the number of dots in pattern 10 is 2 plus 3 times of 10, resulting in 32. Then in part B, well, we've already found our answer from this working over here. So we'll just copy down Tn is equals to 3n plus 2. Followed by part C, which pattern is made up of 233 dots. So we're going to reverse this formula over here. When 3n plus 2 is equals to 233, we will end up with 3n equals to 231. N equals to 77. In other words, pattern number 77 has 2, 3, 3 dots. Okay, so here we have example number 8. 3 patterns, three diagrams shown for this pattern. Draw the next pattern. So this is another type of question. Pattern number 4. Please use your ruler. We see that pattern number 1 has 1 square. Pattern number 2 builds on pattern number 1 with 1 square on the left, 1 on top, 1 on the right. So pattern number 3 is actually made out of pattern number 2. Over here, I'm going to outline. This is pattern number 2. But now we're going to add another one on the left, another one here, top, right, and on the bottom right. So pattern number 4 will have a total of, this is 1 square on the base, 3 square on the base, 5 squares on the base, 1, 2, 3, or 5. Then this must have 7 squares on the base. 1, 2, 3, 4, 5, 6, and 7. With this as the base, let's continue with the next level. Continue again, next level. And finally, the top. So this is our pattern number 4. So complete the table below. We notice that the number of squares will be the square of the pattern number. So this will be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This must be 25. So for part C, to write down an expression, this will be n squared. Answer for part A. For part B, number of squares will be 50 squared, resulting in 2500. This is part D. And next one, part E, which pattern has 748 squares. So we let n square be 784. N must be square root of 784. We know that there will be a positive and negative value, but pattern numbers cannot be negative. So we're going to reject that, leaving us with only the positive value. So here, this will result in n equals to 28. Part F is that a pattern formed using 1000 square. So another way of phrasing this is 1000 a term in the sequence of 1, 4, 9, 16, and 25. So we will assume that 1000 is a term. So let n square equals to 1000. Then find the value of n. We are hoping that n is going to be a positive integer. Because if it is an integer, it will be a term. If it is not a positive integer, it will not be a term in the sequence. And quite clearly from here, we know that 1000 is not a perfect square already. So we know it is not a term. But let us just write down what we have. N is going to be 31.622, which is not an integer. So there isn't a pattern formed using 1000 squares. Okay, so this is the way we phrase our explanations whenever we are asked whether a term is part of a sequence. Example number 9. This is line 1, 2, and 3. Next line, number 4, we see that it is always made of 1 cube plus 2 cube plus 3 cube, and we end at the 4th cube. Okay, so for part A, line 4 looks like this: 1 cube, 2 cube, 3 cube, 4 cube, and this value is given by, we can use our calculator to find out. This is given to be 100, and after we write down the value, on the right hand side, we rewrite the 100 as something square. In this case, it will be 10 square. So that is for line number 4. Now moving on to line number 8. So still part A. Line number 8 will be 1 cube, 2 cube, 3 cube, 4 cube, 5, 6, 7 cube, 8 cube. Using our calculator, we find that this is 1296. You square root this value, you get 36. So we are rewriting this as 36 square. Okay, so the next part B, write down an expression for P and for Q square. Now let's start with Q square first. Q square is easy because it is supposed to be equal to 441. This implies that Q has a value of square root 441, which is 21. Okay, now on the other hand, P over here is whatever is on the left hand side. It is not as straightforward this time. Okay, but we do know that it will start off with 1 cube plus 2 cube plus 3 cube plus 4 cube. Now at the line, when I come to 4 cube, I know that this value is actually 100. It is not enough. So let us add on 5 cube. Now 5 cube is 125. Added to 100 is still insufficient. Let us add a 6 cube. And at this point, we calculate that it is the same as 441. So this must be the value of P. Now in exercise 10, we are supposed to draw the next figure in a sequence. So figure 4. We see that the bottom is all made up of triangles. In figure 1, we've got 2 white triangles, followed by 3, followed by 4. Now the next one must be 5 white triangles. 1, 2, 3, 4, and 5. So let's remove this. And we always have black triangles in between, so shade them properly. After this, we have more white triangles on top of the black triangles. So this is just observation, and this is our figure number 4. So copying down the figure, the number of black triangles, and these black triangles, they are denoted by the letter B, according to the table. So you got 1 black triangle, 2, 3, the next one we have 4. And we see that it corresponds with, the number of black triangles corresponds with the figure number. So quite clearly, in figure number 5, there must be 5 black triangles. Okay, so the number of white triangles, slightly more complicated. There are 2 rows. Now, here we have, they are offering us a pattern. It is always 2 times of something. Then you always plus 1. 2 times of something plus 1. These are the constants. So we can safely go ahead and write now 2 times of something plus 1 equals 2. 2 times of something plus 1 equals 2. So let us take a look at these values over here. Okay. How do we obtain this value of 1? And we compare it with our figure number, because we always want to find out the term number, or in this case, the number of white triangles or black triangles in relation to its figure number. So we will compare these 2 values. And we see that it is very straightforward. These highlighted numbers correspond to the figure numbers. So this must be 4 and this must be 5. Calculating them, this is 8 plus 1, which is 9. 10 plus 1, 11. And we notice that on the right hand side, it also follows a pattern. They are all odd numbers. Specifically, we start with 3 and we keep adding 2. Right, so let us move on to part C. Write down an expression in terms of B So these are the B values over here, which corresponds to the figure number also. Part C, number of white triangles is equal to, write down exactly what we see. It is always 2 times of something. 2 times of, we observe that it is B plus 1. Simplify to become 2B plus 1. That's the answer for part C. So next, part D. If a pattern has 45 black triangles, 45 of them, how many white triangles are there? Now we know that 45 black triangles will correspond to the figure number. Okay, the B value is the same as the figure number. And this particular B value is highlighted over here in my formula. So, number of white triangle is going to be 2 times of 45 black triangles plus 1, resulting in 91. Part E. Let me write it over here. If it has 77 white triangles, how many black triangles are there? So our formula for white triangles is 2B plus 1. And we now know that there are 77 white triangles. So we substitute 2B plus 1. We equate 2B plus 1 to be equal to 77. Then we solve for B. 2B is equal to 76 and B is equal to 38. Black triangles. Done. So for the rest of this period, plus your homework for today, which is Thursday, please complete exercises 11 to 13.